find the area under a curve. We're going to dive right into this. And what we're looking at are definite integrals, integrals that have values below and above the integral. This tells you that we have a definite integral, and we're looking for the area underneath this this function right here between x is 0 and x is 3. So let me separate this first as a function and then graph it. So we have the function f of x equals 4. That is a horizontal line. One, two, three, four. Okay, the horizontal line goes here. Okay. Now, we want the area between x is 0, right here, and x is 3. The shape that we're creating is called rectangle. And the area formula for a rectangle is base times height. So, from here, the base, which is from here to here, is going to be 3. And the height of this rectangle from here to here will be a total of 4. So this will give us an area of 12. And therefore we conclude that the definite integral from 0 to 3 of the function 4 dx is equal to 12. This is the area under the curve 4 between 0 and 3. Let's see, look at number 2. Our function that we're considering is x minus 4. Okay, so I'm going to graph that and find the area between 4 and 10. Let's erase this. Okay, so my y-intercept is negative 4. My slope is positive 1, so I'll go up 1 over 1. Okay, and this is my graph, y equals x minus 4. Okay, so at x equals 4, it's right about here, and x equals 10 is about here. Okay, the shape that we just formed is a right triangle, and we want the area underneath this curve down to the x-axis. So for the right triangle, the area is 1/2 base times height, and the base of this triangle is from 4 to 10. That's a base of 6. To find the height of this triangle right here, I have to put the value of 10 into the function. So we'll put f of 10 here, and we'll get 10 minus 4, and we end up with 6. So this is the height. So the area will be half of 136, which would be 18. Therefore, we conclude that the area between 4 and 10 of the function x minus 4 dx is equal to 18. Number 3. We want to find the area of the curve of this function right here between 3 and 6. So the function that we're considering is the function 2/3 x. Let's graph that. X-intercept is 0, and the slope will be 2/3. So we're going to rise 2 and run 3. Okay, now I want to go to x is 3. So x is 3, and where x is 6. And this shape that I just created here is a trapezoid. The area formula for a trapezoid is 1/2 times base 1 plus base 2 times the height. Now, typically the look of a trapezoid is this. There's your base 1, there's your base 2, and there's your height. This trapezoid has this look, where the base 1 is over here, the base 2 is over there, and the height is from here to here. So, to find base 1, I need to put 3 into the function so I can find out the y value. So, f of 3 is 2/3 times 3, which is 2. That's my B1. Find B2, which is this side over here, the other base, we're going to put in 6. Okay, so now I have B1 and B2. Now what will serve as the height is this portion right here, from 3 to 6. And that's going to be a distance of 3. So we put our B1, our B2, and our height of 3 here, and we simplify. And we get an area of 9. So we conclude that the integral from 3 to 6 of the function 2/3 x dx will be 9. Okay, number 4. We're looking for the area between 4 and 8 of the function -3/4 x plus 6. So I'm going to graph my function. My y-intercept is 0, 6. My slope is -3/4, so I'm going to go down 3 and over 4. Okay, so that's my graph. Okay, now I want the area between 4 and 8, so let's go out to 4. And then we'll go out to 8. Okay, this creates a triangle. And the area formula for triangles is 1/2 base times height. Okay. The base of this triangle is from 4 to 8. That means it's 4. The height of this triangle here I can find by putting 4 into the function f of x. and I find that the height will be 3 when you put 4 into the function f of x. So the area of this triangle will be 6. Therefore, the definite integral from 4 to 8 of this function will be 6.